Hello friends, in this video let us solve one problem on simply supported beam using virtual work. Here we are supposed to find the support reactions for this simply supported beam under given loading. Before solving this problem, let us discuss in brief what is meant by virtual work. In actual practice, beam doesn't move by any displacement, but still we are going to give virtual displacement at different load points, and we are going to write expression for virtual works done by different forces, and finally we are going to equate the net work virtual works done by forces is equal to 0 as all the works are virtual. That is the logic behind solving this problem by virtual work method. To do so, let us keep one of the end fixed and move other end by small displacement. Before that, let's say the support reaction at this left end is R1 and support reaction at this right end is R2. Now keeping this end fixed, let us move this end by some small displacement. Say this displacement is delta. Now let us extend these line of action of forces. Now say this displacement is x and this displacement is y. Now let us find these displacements. These are virtual displacements. All these three are virtual displacements. Let us find these two values x and y in terms of delta by using geometry. By using geometry, this entire span length is 8 meters. Distance of this force is from this left end is 5 meters, whereas distance of this force is 3 meters from left end. Now we can write here delta upon this total distance is 8 meters is equal to x upon this distance is how much? It is 5 meters. This implies x is equal to 5 by 8 delta. Similarly, this y upon 3 is equal to delta upon 8. This implies y is equal to 3 by 8 delta. We got virtual displacements in terms of delta. Now let us write expression for net virtual work. The work done by this support reaction R1 is 0 because there is no displacement. Now work done by this 40 kilonewton force is 40 into this displacement is y, force into displacement it is work. Y is equal to how much? It is 3 by 8 delta. 3 by 8 delta. See, displacement is in the same direction of applied force, therefore let us take this as positive work. Now work done, virtual work done by this 70 kilonewton force is 70 into this displacement x in terms of delta is 5 by 8 delta. This is also positive work because displacement is in the direction of applied force. Now work done by this support reaction R2 into this displacement is delta. See, force is acting upwards and displacement is in downward direction. It is opposite to the direction of applied force. Therefore, we have to take this as negative work is equal to 0. Net work done is equal to 0 because this is virtual work principle. Now delta will get cancelled from everywhere. Now let us multiply this equation by 8 for the equation 40 into 3 plus 70 into 5 minus 8R2 is equal to 0. Therefore, R2 is equal to 120 plus 350 upon 8 is equal to 350 plus 120 is 470. 470 upon 8, 8 1 8. This is 58.75 kilonewton. We got support reaction at right end. Similarly, we can find, see, I will write this answer here. R2 is equal to 58.75 kilonewton. Now let us find another support reaction, that is R1. To find R1, what we will do, we will keep this right end fixed, and let's move this left end by small displacement. See, this is the new diagram. $70 kilonewton. This is R1. This is R2. This is virtual displacement. This is again virtual displacement. Let us consider this as X, this as Y. Now, once again, we will find the value of these virtual displacements. Now, again using geometry of the figure, what we can write, this value is say delta. Okay, this delta upon 8, this upon this entire span is 8, is equal to x upon this distance. This distance is 3 meters because total is 8 meters minus 5 meters. This distance is 3 meters. X by 3. This implies x is equal to 3 by 8 delta. Again delta by 8 is equal to y upon this distance. See, this distance, the entire distance is, total distance is 8 minus this 3. This is 5. It is 5 by, y by 5. This distance upon this distance is 5. This implies y is equal to 5 by 8 delta. Now let us write expression for net virtual work. Now virtual work done by this reaction, support reaction at left end is R1 into delta. The force is in upward direction and displacement is in downward direction. Therefore, we have to consider this as negative work. Now this 40 kilonewton force into displacement work. Y value in terms of delta is 5 by 8 delta. Displacement is in the direction of force, therefore let us take this as positive work. Here also same case, 70 into x, displacement x in terms of delta, 3 by 8 delta. Displacement is in the direction of applied force, therefore this is positive work, is equal to 0. The net virtual work done is equal to 0. Now delta will get cancelled from everywhere. Now let us multiply by 8 throughout the equation. What we will get, minus 8R1 plus 200 plus 210 is equal to 0. Therefore R1 is equal to 410 divided by 8. This is 51.25 kilonewton. R1 is equal to 51.25 kilonewton. This is the easiest way of finding support reactions. Here we have not taken any moments, we have not added any forces, just we have written expression for virtual work and we have equated that net virtual work is equal to 0, and finally we got the answer for support reactions. I hope you must have understood this method of virtual work for solving support reactions of simply supported beam. We will meet again in the next video with another concept or problem. Till then, goodbye. Thanks for watching.